On number 15C, it says that a line is parallel to x-axis. Okay, so we want to find the direction for this line. Okay, let's say this is the x-axis. Let's say this is y. Let's say this is z. Alright. How is a line going to be parallel to x? This way. When I'm saying this way, it doesn't have y value. Doesn't go up, doesn't go down. Doesn't have z value as well. Doesn't go up in front, doesn't go back. It's only parallel to x. It has only x value. Okay. So y and z are not there. So if you take x, y, z as I, j, and k, now it doesn't have y, it doesn't have z. So your value of j and k is 0, 0, 0. The problem is it has only y. It's only I, x. So if it has only x, normally we write it down as 1, 0, 0, the direction. Right? Sir, I don't want to write down 1, sir. I want to write down 1 million. It's okay, acceptable in a sense. Alright? As simple as that. Now let's go for something else. Let's have a look on number 17. Number 17, it says is perpendicular to the plane. Perpendicular to x. Axis. How is a plane perpendicular to x axis? Let's do like last time. We got ourselves x axis, y axis, z axis. How is a plane it's going to be perpendicular to x? How does it look like? Like this? Like this. You okay? So the y and z are not there. So it's like this. So what if a plane perpendicular to x axis? This is also the same as what? This is the direction, yeah. What direction to the plane? The plane has a direction where? The normal. Okay. So what can we say about this normal and this x-axis? They're the same. So this normal is equals to what? What value should I put? Yeah, it's the x-axis. What value should I write down? Just now we write down what? 1, 0, 0. So the direction for this normal is 1, 0, 0. Are you okay? Am I too fast? Do you want me to explain again? You guys okay? Right, good. Okay, now what about if number 17B, it says that parallel to XZ plane. Okay, this time parallel to XZ plane. How is the plane perpendicular to XZ plane? Okay, firstly, where is XZ plane? Let's see. Yeah. X and Z, right? Our plane going to be parallel like this. Are you guys okay? You guys okay with this one? Okay. So if it's parallel to XZ plane, what does it also mean? Perpendicular to y axis. So what if it's perpendicular to y axis? What does it mean? It's parallel to its normal. Okay, now we're taking y-axis as what value? If x-axis is 1, 0, 0, this one? 0, 1, 0. Okay, you understand? So the normal is 0, 1, 0. Right now let's go something else. This time a plane. Can I wrap this one off? Is parallel to plane, another plane, 3x minus y plus 2z. Okay, now it's parallel to another plane. How is a plane parallel to another plane? So how does these two planes interact? Something like this. Start from here. It's parallel how? Like this. Right? So what if they are parallel? If they're parallel, so what? They share? Good. This guy normal. Hold this. This guy normal is the same as this guy normal. Are you okay? You see both of us? So they share the same normal. Right, this plane, what is the normal right now? What's the value of this normal? Do we got any equation for that? We got that. Okay. The equation for that plane is here, 3x minus 2y plus z. So what's the normal for that guy? 0, 1, 0, y. Can you find normal in here? It's 0, 1, 0 if it's perpendicular to y axis. In this case, it's not. You need to understand that one. Right? So what's the normal for this guy? What's the formula for a plane? R dot n equals to A dot n. A dot n is this 4. Is this 4 normal? No, this is A dot n. What is R? R is x, y, z. So what is n? N is the normal. Can I find normal over here? 3, negative 2, 1. So the normal for that plane? The normal for this plane? 3, negative 2, 1. What's the normal for this plane then? The same. 3, negative 2, 1. Why are they the same? They are parallel. Okay, the plane parallel, so that is the normal, and normal is also parallel. You guys okay? And thank you very much. Okay, I have one more question, which is one moment. Okay, number 18A, it says that a plane. Can I wrap this one? Let's try this time. A plane pass through 2, negative 1, 1 and also contain vector, these two vectors. Alright? So what does it look like? Okay, so how does a plane pass through 2, negative 1, 1? What does it mean? What is this 2, negative 1, 1? That's the A, that's the point on the plane. This is the A. What is this? These two. Share direction. Direction 1. This is direction 2. So how does a plane have those things? So where is the A with the plane? Just something like this. Are you okay? It can be anywhere. So let's just say that. Now, what about this? How does a plane contain these two vectors? Let's have a look at this one. 3, negative 1, 1. Where is this 3, negative 1, 1 with the plane? Is it like this? This is perpendicular, not contained. Is something like this? No. This is contained. Understand? Does it touch the line? We do not know. Let's just take it like that. Right? And there's also another vector. 1, 2, 1, 2, 3, where is it? Where is it? It's also contained there. Understand? Contained is like this. Now, is these two vectors parallel? They are not parallel. As you can see in the equation, they are not parallel at all. They are not a multiplier of each other. So, if it's not parallel, what does it mean? It can cross. It can cross up, something like this. If it cross, what happens? Two vectors cross, what do I get? I get one normal. So if I cross these two vectors, I get myself, the force is strong. I get myself a normal. Understand? Right? Why do I need the normal? What's the equation of vectors again? R dot n equals to A dot n. This is the n. Right, this normal is the n. What's your A? Point on the point, then take this one, which is that one. Understand? So basically it means these two, what do I want to do? I want to cross them up and I get the normal. This is the A. What's the formula again? R dot n equals to A dot n. This is your A. Whatever value you got over here, that will be your n. That's how you solve that. Right? So those are miscellaneous stuff. I hope you can do them. Alright, that's all. Thank you. Just comment, share, that.